Okay. View. Present. All right, boys and girls. My name is Abigail Wallace, and I will be teaching you lecture 27, or reviewing it, I guess. So hopefully this is helpful in the slightest to any of you. We're going to be going over limiting reactants and percent yield. All right, let's get to it. So the first thing we need to know is to have an understanding of what a limiting reactant is, because how can you find it if you don't know what it is? So I think for me, when I am going through a test and I don't know what something means, I just try to break up the word and find the definition of what both of them are. So here we have a limiting reactant. First, I'm just going to focus on reactant. Hopefully by this point in the semester, you know what a reactant is. Here's an example of a chemical equation down here. Wait, I want my little laser pointer. Way cooler. Yeah, okay. So basically reactants are the ingredients that are used to make a product, and they're always going to be on the left side of this arrow. Also, he uses the word reagent in lecture as well. Just know that they mean the exact same thing. They're interchangeable. Okay, so we know what a reactant is, and now we just need to know what limiting means. So limiting means literally to limit. So it's going to limit the amount of product that we can make. And also, we need to know that in a reaction like this, the limiting reactant is going to be completely used up in the reaction. There will be none left over. We use all of it. So there you go. Okay, so this is a really dumb or simple example that I remember like learning about in elementary school. So I thought I'd bring it back because it's very simple but very helpful. So I have 3 shirts, 2 pants, and 4 pairs of socks. And one outfit or one product is 1 shirt, 1 pair of pants, and 1 pair of socks, because that's what you wear in an outfit. So from all of these reactants, which one is the limiting reactant? So obviously the pants, there's only 2 of them. So I can only make 2 outfits for my pants. With the socks, just looking at the socks, I can technically make 4 outfits. With the shirts, I can make 3 possible outfits. And the lowest amount, or the one that limits the amount of product that I can make, is the pants, because I can only make 2. I can't make any more. So it's going to limit these guys into how many outfits they can make. Therefore, the pants are the limiting reactant. Okay, another term we need to know is what is an excess reactant. Same thing, we already know what a reactant is. And this time, instead of limiting, it's excess. And excess, we know, means extra or left over. And so it means that after a reaction occurs, let's go back. After this reaction occurs, that there is going to be some of the reactant left over after we have already formed our product. Again, with this example, one way you can know is, okay, if it's not the limiting reactant, then I already know that these guys are the excess reactants, because there's only one or the other. Can't. Another way is you look at this and you say, okay, there's from the pants, I know that the only possible, or the highest possible amount of product I could make is 2. And so I'm going to say, okay, I'm going to use these 2 in my outfit, which means I have 1 left over. Or I'm going to use these 2 socks in my outfit, which means I have 2 left over. And if there are any left over after the reaction has taken place, then you know they are excess reactants. Therefore, the shirts and the socks are excess reactants. The pants are the limiting reactants. Okay. Now with numbers. So here is a simple chemical equation. Dinitrogen plus 3 dihydrogen is going to be 2 ammonia. Not to be confused with ammonium, which has 4 hydrogens. Anyways, So the question is, how many grams of NH3 can you make if you have 35 grams of N2 and 20 grams of H2? So the first thing we need to do is to find the limiting reactant. So I'm going to take you through 3 different ways that you can find the limiting reactant, and you just pick your favorite. You can use any of them, doesn't matter which, they're all going to have the same result, just a little bit different way of getting there. Okay, so the first one is to find for this question, we're looking for grams. So we're going to find the grams of product possible from each reactant that we're given. Okay. So I'm going to take the 35 grams of dinitrogen that I've been given, and I'm going to convert that into grams of ammonia that I can make from what I'm given. Quick little side note, a friendly tip that has helped me in chemistry a lot is whenever you don't know what to do, literally just look at what you're given and look at where you want to end up and then look at units. I feel like chemistry is basically just finding out which units and canceling them out. At least for me, it's been very helpful. So if you're ever confused, just be like, okay, well, I'm given this in the problem, so I'm going to start with that 35 grams of dinitrogen, and then I'm going to convert units to get to grams of ammonia. So 28 grams of dinitrogen for every mole of nitrogen, and then look at the molar ratio, 1 mole of dinitrogen for every 2 moles of ammonia. And for every 1 mole of ammonia, we have 17.031 grams of ammonia. And really quick, I got this just from looking at the periodic table by multiplying the molar mass of hydrogen times 3, and then adding the molar mass of nitrogen to get the total amount of grams per 1 mole of ammonia. So hopefully you know how to do that, but that's just a quick run through. Just look at the periodic table and add them up if you don't know. Okay, and then look at all my units. Yep, they all cross off. I'm ending with what I want. Okay, so I get 42.5 grams of ammonia from 35 grams of dinitrogen. We're going to do the exact same thing, but with hydrogen. So I'm given 20 grams of hydrogen. I'm going to look at my units, make sure that they all line up, that they're all crossing out, and then I'm just going to multiply across, and I'm going to end up with 112 grams of ammonia. So looking at these 2 different answers, basically what this is saying is, given this amount of nitrogen, this is the greatest possible amount of product that I can make. And given this amount of hydrogen, this is the greatest amount of product that I can make. Well, clearly this one makes a much smaller product, so it's going to limit the amount of product we can make, and it's going to be our limiting reactant, and this is our answer of how many grams of product. Okay, that was way number 1. Second way is to find the moles of product possible from each reactant. So it's going to be the exact same thing, but you're just going to stop a step early. So again, take what you're given, the 35 grams of dinitrogen. I'm going to look at my units, make sure they cross out. I'm going to convert it into moles of product instead of grams of product. So literally it's the exact same thing, but I'm just crossing off this last step right here. This ends in moles, and then this one ends in grams. So it's literally just cut that out. Okay, so I do that for both of them, and I get these answers. And again, it's the same principle. With this given amount of reactant, I can only make this many moles of product, while with this amount of hydrogen, I can make this many moles of product. So I know this is my limiting reactor because it is the smaller amount of moles. So then I'm going to do the same thing I did before. I'm going to convert the limiting reactant into the amount of grams of product. So also another note is you're always going to do the last step, or finding how much product, from the limiting reactant. You're never going to take it from the excess reactant, because then it wouldn't be realistic of how much product you can actually make. Okay, so take that, and same thing, I'm just going to do, this is the same thing as the last step over here. It's just instead of doing it for both of them all the way through, I'm only doing it for one of them. And I'm only going to do it for this one because this is a limiting reactant. So it doesn't matter how many grams of product I can make from this many moles because it's the excess one. So there's going to be leftover. So then I just convert, I get grams, and this is my answer. So yeah, the benefit of that is just you don't have to do all the way through, like do all of the steps. You only have to do it for this top one, if that's helpful. Okay, the last one is to use the molar ratio of the reactants. So I'm going to first convert them into moles. Take what you're given, just divide by the molar mass really is what you're doing. But again, like I said, it's always helpful to set it up like this and just see my units crossing off and make sure I'm ending with what I want. So these are the two amounts of moles that I end up with. And you can't tell anything from here. You don't know which one is the limiting reactant because this is not moles of product, it's moles of reactants. So you don't know which one is the limiting one yet. So we're just going to pick either of them, doesn't matter which. I just chose 9.92. And then I'm going to convert that into the other reactant, into moles of the other reactant. So I'm going to take this amount of hydrogen, moles of hydrogen, and I'm going to convert that into moles of dinitrogen. And I get 3.307 moles. And basically what this means is like for this amount of moles of this reactant, how many moles of the other reactant do I need to make a full product with this amount given? So hopefully that made sense. So with the 9.92 moles of hydrogen, I would need 3.307 moles of dinitrogen to make a full product. But as you can see, I only have 1.249 moles of nitrogen given. So I know that this is the limiting reactant because I have less than I need. It's going to limit the amount of product that I can make. And like I said before, you always do the last step with the limiting reactant. So I'm just going to take that number of moles and then I'm going to convert that into grams of ammonia. And same thing, we get 42.5 grams in the end. Yep. So those are the three different ways. You can do whatever you want. Honestly, I would suggest doing the first one if you're confused at all. The first one is right here because you don't have to remember where to stop or any extra steps to take. It's just start with what you have and then go all the way to the unit of product that you want, so grams of NH3. Just go all the way to the end for both of them, and then it's just very simple. Whichever one is the smallest product, that is the limiting reactant. So that one's the easiest for me because I just like getting it done in one swoop instead of having to like take steps and remember which to do, but you do whatever you want. And then we also want to talk about finding leftovers. So this sounds like exactly what it is. When I think of leftovers, I just think of eating dinner and then having some left over to eat again the next day, you know? That's basically what it is. So if you have 3 watermelons and I only eat 2 of them, then I have 1 left over. Imagine that. And so like in regards to chemistry, I guess, you could say I have 3 moles of a reactant, and if I use up 2 moles of the reactant in an equation, then I have 1 mole of excess or leftover reactant. And again, if there is any leftover, that means it is the excess reactant, not the limiting reactant. So to find the leftovers, it's a simple 3-step process. First, you find the limiting reactant, which we just did in that problem before. We just looked at 3 ways to do that. Step 2, you're going to calculate the amount of excess reactant that is actually used in the reaction. and then you're just going to find the difference to find out how much is left. This is kind of confusing, but it just explains what we're going to be doing in words. So if that's helpful, you can look at that. I'm going to keep going. So this is the same equation, but just a different question that we're going to be using with this equation. So given 1 mole of N2 and 1 mole of H2, this should say how many moles will be left over. So first thing, like I said before, step 1 is find the limiting reactant. So actually with this problem, it's pretty simple. We don't have to do any calculations. You can simply just look and see that the molar ratio between these two reactants is, for every 1 mole of N2, we need 3 moles of H2. And since we are given 1 mole of both, we know that we do not have enough H2 to make the product. And so we know that H2 is going to be our limiting reactant. So yeah, if the given amounts are the same for both of the reactants, then you can just look at the molar ratio and figure that out. And then step 2, we're going to find how much is used. And the way to do that is you're going to convert how do I say this? You're going to convert the moles of one reactant into the moles of the other reactant. Here we go. So I'm going to take what I'm given, 1 mole of H2, and the reason I'm taking H2, not N2, is because it's the limiting reactant. Like I said, always going to be using the limiting reactant in the final equation. So I'm going to take 1 mole of H2, and then I'm going to look at the molar ratio, which is 3 to 1, and I'm going to convert it into moles of nitrogen. And so I know that if I use up all of this mole that I'm given, then I'm only going to be using 0.333, or a third mole of nitrogen. And since I'm given a full mole of nitrogen, then I can just subtract this answer from the full mole that I'm given, and I will end up with 6.666, or 2/3 mole of nitrogen that is left over. Okay, so this is a pretty basic example of this kind of problem. There will be more complex problems like this. And just remember, for any other problems, they could ask you for different units. This was very simple because I just stuck with moles, given moles and going into moles. But you could be given grams, kilograms, or whatever, or be asked to find how many grams or kilograms are left over. And it's going to be the exact same process. Again, just look at your units. I have moles of nitrogen right here. If I wanted to find grams of nitrogen, then I would just simply do another ratio right here and just say 1 mole of nitrogen is this many grams of nitrogen. And then the moles will cancel, and I'll be left with grams of nitrogen. So exact same principle, just look at what you're given, look at where you want to go, and make sure your units cancel. Okay, and then the other thing that you might have to do is the limiting reactant might not be so obviously clear in other problems. So this one was very simple because we were given the same amount of both reactions or reactants. So you could just look at the molar ratio. We didn't have to do any math for that. But if it is different amounts, like say like before 35 grams and 20 grams of this, then you won't know right off the bat which one is the limiting reactant. I know when I first looked at this, I would be like, oh, whichever one's smallest, that will be the limiting reactant, but that is not the case. So if you're ever unsure, just do the math and figure out which one is the limiting reactant, and then do all that math, and then you can do this next step, of finding out how much is left over. So again, the 3 ways you can find the limiting reactant if it's not obvious. Find the grams of product possible of each reactant. So that's just doing dimensional analysis all the way through, and whichever is the smallest product, that is the limiting reactant. Second way is find the moles of the product possible. So you're going to do the same thing, but only convert them into moles instead of grams. And then you're going to, whichever one has the smallest amount of moles, that is a limiting reactant. You take that amount of moles, of the limiting reactant, and you convert that into the grams of product to find that. Or the molar ratio of the reactants. So you're just going to take what you're given. Maybe you're giving them in moles, so you don't have to do any conversion there. But if you're giving them in grams or kilograms or whatever, you're just going to take what you're given and then convert it into moles. And then, let's go back really quick. Yeah, convert it into moles and then just pick either of the answers you get and use the molar ratio to convert it into the other reactant to see how much is needed. Then compare how much is needed with how much you have. If it's less than what you need, you know it's the limiting reactant. If it's more than what you need, you know it's the excess reactant, and this one is the limiting. And then, yeah, just take that, convert it. Okay. Okay, and last thing we need to go over is percent yield. Here's the equation for it. Actual yield over or divided by theoretical yield and then times 100. So really quick, I'll go over these terms right here. The actual yield, I just remember because this is what actually happens in real life. Like if I am conducting an experiment or if I am actually doing the reaction, this reaction right here, if I'm actually doing that in real life, then the actual yield is going to be what I actually end up with measured. The theoretical yield is going to be, in theory, that's how I remember it, in theory, this is what I should end up with. After I calculated it and used my equations, this is what should happen. And the reason there is a discrepancy between these two is because of human error. Whether you measure something wrong or environmental influences are affecting it, or you just lose some product along the way, there's always going to be a discrepancy here. So you're gonna divide them and then just multiply by 100 to get a percentage, obviously. A couple things to remember about percent yield is it can never be over 100, and it will never be 100 really, because if it was 100%, then that would mean everything was perfect and there was absolutely no error in your experiment, which never really happens because we live in an imperfect world. So I would be very skeptical if you got 100%. Also, if you get more than 100%, then you know you did it wrong and you need to recalculate because you will never end up with more product than you than you calculated. You're going to lose some along the way. Second thing is you are going to calculate theoretical yield. That's where you do your math and find out, like, in theory, this is what should happen. And then you will be given the actual yield from an experiment. It should say in the problem, like, this is what actually happened. And then you calculate, oh, this is what should happen. Then divide, multiply by 100. And there you go. Okay. And that is the end of my slides. I hope that was helpful. I hope I did not teach you anything incorrectly. But as far as my understanding, that is lecture 27. Good luck on the test.